Well, now we know in this first problem here that the interior angles of a triangle, their measures add to 180 degrees. So we're going to have this equation here that 46 plus 95 plus x is equal to 180. And adding here, we're going to get 141 plus x equals 180. And then we're going to do a subtract that 141 from both sides, and doing so will give us x equals 39. So we're going to say that the missing measure is 39 degrees. This triangle here in problem number 2 is an isosceles triangle, and I know that because these two sides are equal in length. And in an isosceles triangle, you have two sides that are equal in length, and the angles opposite those sides are equal in measure. So this measure is 79 degrees. It's opposite that side. So opposite this side is this angle. That's going to be 79 degrees also. So we know that that's going to be 79 degrees. And now we know that because the interior angles, measures of those interior angles add to 180, we can write this. We can write that, we'll see if we can write it, that the measure of angle A plus 79 degrees plus another 79 degrees, that's equal to 180 degrees. Add those two together, we'll get the measure of angle A plus 158 degrees is 180 degrees. And now let's subtract that 180. So we will get the measure of angle A equaling, now 180 minus 158, I got 22. So the measure of angle A will claim to be 22 degrees. We've got a parallelogram here, and what we know in parallelograms is that opposite angles have equal measures. So this angle here, D, is opposite to angle B. Angle B is 102 degrees, so angle D must be 102 degrees. Now here's something we also know, that in any quadrilateral, any four-sided figure, if you add up the measures of the interior angles, the measures of the interior angles always add to 360. Now just think back over here to these, like memory number 1. This was a triangle. In a triangle, a three-sided figure, the measures of the angles add up to 180. We've got a quadrilateral, a four-sided figure, so the angles, measures of the angles add up to 360. So let's add these up here. So we're going to get that the measure of angle B plus the measure of angle D plus the measure of angle A plus the measure of angle C, that's all equal to 360. Now we know B and D, so starting here with these two here on the left, we're going to get 102 degrees plus 102 degrees plus the measure of angle A plus the measure of angle C. That's all equal to 360 degrees. Now here, this is 204 degrees plus the measure of angle A plus the measure of angle C. That's 360 degrees. Let's subtract this 204. So doing so gives us the measure of angle A plus the measure of angle C is now 360 minus 204 is 156 degrees. Now because these two are equal, A and C have the same measure, we could just write this, that 2 times the measure of angle A is equal to 156, and then divide by 2. What we'll get here is the measure of angle A is equal to, now dividing by 2, we're going to get 78. And that's just what we're looking for, measure of angle A. What we have here is a circle, and this angle, and this is called a subtended arc. This arc is subtended by these two chords. Now a chord is a line segment that starts from one side of the circle and goes to the other side. It doesn't have to go through the middle, just from one side to another. Here's another chord right there. So I've got this chord and this chord. They make an angle right here, and we're given that that angle is 21 degrees. And this right here then is the subtended arc. Now, here's a fact. Let's read it. It says an inscribed angle, and that's what we have. We have an angle that's inscribed in this geometric figure. That's angle B. So that inscribed angle has a measure that is 1/2. So the measure of this angle is 1/2 the measure of its intercepted arc. Now, this arc is the intercepted arc, right? If you take these chords, we get this arc right here. So this angle here is 1/2 of this measure right here. So the theorem says that the measure of angle B is 1/2 that intercepted arc, and the arc is AC. I'll write it like that. So if we multiply by 2, we will get 2 times the measure of angle B is equal to the measure of that arc. Angle B is 21 degrees. That'll be the measure of that arc. So we get 42 degrees is the measure of that arc. Well, it looks like there's a lot going on here, number 5, but what we want to do here is just to identify the chords. So a chord is a line segment that cuts through a circle here that touches both sides of the circle. So here's one. How about this part right here? We could label that CG. And there's another one too. How about this one? BC. Looks like that diameter. We're given that O is the center of the circle. So BC, that goes from one side of the circle to the other. So let's write that one down. BC, and that's all I think we've got. We've got this one here and this one here. So those are the two chords that we're looking for. Now, using the same picture that we had back in number 5, using this one, what we want to do is identify the minor arcs. So here's a definition of a minor arc. A minor arc of a circle is an arc that has measure less than 180 degrees. Now, back here in problem number 6, or number 5, we have a circle and we have some arcs. And it is helpful to know that this angle right here, coming right from the center, this is called a central angle. And the measure of a central angle and the measure of the arc, subtended arc, are the same. So if I take this central angle here, it has a certain measure. And then that's the same measure of this arc. If I take this central angle, right, here's a central angle, and then I take this arc that's subtended by that angle, they have the same measure. Now, down here, what we're saying is that a minor arc is the arc of a circle that measures less than 180 degrees. So if we look back up here, look at this angle here. Now it appears to be less than 90 degrees, so that means this arc is going to be less than 90 degrees. So we can say then that this is a minor arc. So we can write that as a minor arc. Let's say BG, that's going to be a minor arc. And what about this one? This one here, well, that's less than 180 degrees also. So we can claim that GC or CG is also a minor arc. So we'll say that CG is also a minor arc. And I think that's all the minor arcs that I see. If we look at this, okay, actually, here's an angle here, right, from BOC, but that's 180 degrees, and we want one that's less than 180. This one here, that's 180. We want less than 180 degrees. So I'm seeing only this one and only this one. So we got a lot of lines going on here in this problem number 7, but what we're given is this. We are given that this angle here, BOG, so BOG, this angle right here is 52 degrees. So let's make note of that. So this is a 52. And what we want to find here is what is angle BCG. So let's find it. BCG. We want to find the measure of this angle right here. Now, some things we know. This is a central angle, and the central angle has an arc with the same measure. So this arc measure right here is 52 degrees. So let's note that. So we know that the arc of B to G is also 52 degrees. And then this angle that we're looking for, BCG, this is an inscribed angle, right? It's inscribed because it's the vertex is on the circle and we have two chords. So this is an inscribed angle, and inscribed angles have measures that are 1/2 the arc. So this angle right here is the one we're looking for, and this measure is going to be 1/2 of this intercepted arc. And if this intercepted arc is 52, half of 52 is going to be our angle right here. So we can say that the measure of angle BCG is equal to 1/2 of BG, of that arc. So this is going to put us at 1/2 of 52 degrees, which is 26 degrees. We have a circle with this diameter right here, this chord, and this tangent line. And here's what we're given. We're given that the measure of angle ABC. Now here's ABC. ABC, right? So B, remember the middle, that's the vertex. It goes ABC. That measure is 53 degrees. What we're trying to do is find the measure of this arc right here. Now, there's a lot of lines here, but let's not get lost in that. Here's what we have. This, I think, looks worse than it is. Look at this angle right here. This is a chord. This is a chord, so this is an inscribed angle, right? This is an inscribed angle, and we know that the inscribed angle, the measure of that, is half of the measure of the intercepted arc. So let's write that. We know that the inscribed angle, the measure of ABC, is equal to 1/2 of the intercepted arc. And that's the arc we're looking for, AC. So this is half the arc AC. Now, the angle ABC we're given is 53 degrees. That's equal to half the arc of AC. And if we multiply by 2, right, multiply by 2, we'll get that arc AC being 106 degrees. In problem number 9, we're asked how many diagonals can be drawn from a single vertex of a nonagon. Okay, so we need to really understand what a diagonal is. So here's the definition of a diagonal. A diagonal is a line segment. Okay, a line segment starts and stops, right? Doesn't go on forever. So it's a line segment that joins any two non-adjacent vertices. Let's draw a couple. So suppose we have a triangle. Let's see if we can draw it here. Here's a triangle. Now, if I'm at this vertex right here, this vertex is adjacent and this one is adjacent. So we have 0, right? I can't join this. I can't join this one and this one because I wouldn't have diagonals because they're adjacent. So the answer here would be 0. Now, what about a square? Well, in a square, pick a vertex, like maybe this one. So there's 4 of them. If you pick one, like maybe this one here, now I have to take a line segment and join a non-adjacent vertex. So this is out, and this is out, right? Because those are adjacent. So I have only one, and I can draw that one. So that would be a 1. Let's take a look at a 5-sided figure. 1, 2, 3, 4, 5. Now we've got 5 vertices, and there's 5. So pick one. Maybe I pick this one here. Okay, so I pick this one here. Now, how many diagonals can we draw? Well, from here I can go over here. That's 1. I can go over here. That's 2. But I cannot go here. I can't go here because these are adjacent next to each other, and these are next to each other. So this is out, and this is out. So what I've got here is 2 of them. There seems to be a pattern shaping up here. If we have 3 sides, we have 0. If we have 4 sides, we have 1. if we have 5 sides, we have 2. So it looks like what we're doing here is, if I have 3, I have 0. So 0 is 3 less than 3. Here I have a 1. 1 is 3 less than 4. Here I have a 5-sided figure, and I have 2, which is 3 less than 5. So it looks like the number of diagonals is always 3 less than the number of vertices. And that should make sense because, like, you're right here, that takes one of them away, and then the 2 adjacent, that takes 2 more. So there's three vertices that have to be subtracted out. So let's write what we just said here. So the number of diagonals that you can draw is from a given vertex is equal to the number of vertices minus 3. So if we have 9 vertices in a nonagon, minus 3, we're going to claim that there's 6 diagonals that we can draw. Problem 10 here, we've got a transmitting tower here that's supported by this wire that's attached to the ground, and we're given that the wire makes an angle of 53 degrees to the ground. So I'm going to assume that that's 53 right in here as opposed to over here. Right, so let's assume that's 53 degrees, and then we'll also assume that it's a transmitting tower. Let's assume that that's a 90-degree angle. So what we want to know is, what is the angle? What's the measure of the angle between the tower and the wire? Right, so what is this angle right in here? What is that? So let's call it x. And it's a triangle, so we know that the measures of these 3 angles have to add to 180. So we're going to have this, x plus 90 degrees plus 53 degrees. That's got to be 180. So this is x plus, okay, so how about 143 degrees equals 180? And then if we subtract that 143, we're going to get x equals 37 degrees. So we're going to say that that angle is 37 degrees. Okay, and we're saying that that's what that angle is right there. The last problem we're going to do here says this, that we've got some city here and the streets meet at these angles. So here's a street and here's a street. There's a 90-degree angle here. Here's this diagonal street. This makes an angle here of 42 degrees. These streets here make an angle of 63 degrees, and what we want to do is find this angle here. We're asked to find this angle right here. Now, if we knew this angle, I'd know that this angle plus this angle is 180, so the angle we're looking for would be 180 minus whatever this is. We need to see if we can get that angle here. Now, what if I knew this angle here? Then I would know that this angle plus this angle plus this angle is 180. So, can we get this angle? Well, it turns out I think we can. Let's see what we've got here. You know, back over here, this is 90 degrees right here. So this angle right here, that's 90 degrees. And then what we've got is this angle plus this angle has to give us 180. So what we know is this. So in this little triangle right here, we know that, let's see if I can get it to right here, 90 degrees plus 42 degrees plus, you know what, let's call this angle y, plus angle y, this is 180 degrees. Adding these together, that gives us 132 degrees plus angle y is 180 degrees. And then 180 minus 132, right, what we're going to do is subtract this number here. So we'll get y is equal to 48 degrees. So this angle y right here, this angle y is 48 degrees. Now, if you know that this one is 48 degrees, look at this one right here. These are vertical angles, right? Vertical angles are ones that are just opposite of each other. So if this is 48 degrees, this has to be 48 degrees. So let's label that as 48 degrees. And now, if I call this one z, I know that 48 plus 63 plus z is 180. Let's write that. I'll do it up here. Let's say 48 degrees plus 63 degrees plus angle z That's equal to 180 degrees. Add these two together, I got 111 degrees plus z is equal to 180 degrees. And then if we subtract that 111, we're going to get z is equal to, I got 69 degrees. Now we've got that this angle here is 69 degrees, so we know that z plus x is equal to 180 degrees, but z is 69 degrees. We'll have 69 degrees plus x equals 180 degrees, and then if we subtract that 69 degrees, we're going to end up here with x being equal to 111 degrees. So this one was quite an adventure, right? We wanted to get x, so to get x we had to get z, but to get z we had to get this one, and to get this one we had to get this one. And to get this one we had to know that this was 90 degrees and that the sum here was 180.